Welcome, and thank you for joining us for this webinar presentation. We are the Defense Systems Information Analysis Center, or DSIAC, one of 3 IAC domains in the DoD Information Analysis Centers operating under the Defense Technical Information Center, DTIC, within the Office of the Undersecretary of Defense for Research and Engineering. Our informative webinar series highlights current and emerging research and technology developments. It presents an opportunity for accelerating the DoD's leverage of these advancements by increasing awareness and fostering technical collaboration. DSIAC serves as one of the premier information research partners and curators of technology advancements and trends for the defense systems community. As such, our organization supports those working in the defense systems domain of DoD research and engineering. We do so by helping navigate the vast landscape of scientific and technical information, allowing our customers to get a head start on their technical projects. With an understanding of the defense system's DoD research and engineering landscape, we provide research and analysis services. We help unlock access to information, knowledge, and best practices from government, industry, and academia to stimulate innovation, foster collaboration, and eliminate redundancy. We hope you enjoy this webinar presentation and that it serves as a catalyst for community collaboration and improved DoD defense systems research.
Right. Well, good morning, good afternoon, evening to everybody who is joining us. I appreciate you taking the time out of your day to take part in this webinar that Kevin is going to present for us. So my name is Brian Benish. As I'm going to be introducing Kevin. You can go ahead, Kevin, and bring up your slides to start sharing them. Just a few words of introduction while that's happening. First of all, if you have any technical issues with the webinar as it's being conducted, first of all, rest assured it's being recorded so you can access the video later on. If you would like to get the slides, they are available on the DSIAC webinar webpage for this particular webinar. Should just be a download button and you can grab them from there. If you are in the WebEx platform, I want to draw your attention to a section called Q&A. Hopefully you can find that. You might need to hit the 3 ellipses, 3 dots, maybe on the bottom right of your screen or somewhere else, depending on how you're accessing it. You'll see, once you click that, you'll see Q&A. There should be a little message prompt where you can enter your question for a Q&A portion. I want to distinguish that from the chat. There's a chat feature where you're welcome to send notes to myself or Kevin at any time throughout the presentation. But if you have a question you'd like Kevin to answer, I want to make sure you get that into the Q&A section so that we can use them at the end of the presentation. And so Kevin will have the floor to give the presentation, and then we'll go into the Q&A, and I'll jump in to help moderate that a little bit. But again, if you have any technical issues, it is being recorded. You can reach out to us at DSIAC, or contact@dsiac.org, and we can help you with any other questions you might have. And so as a matter of quick introduction for Kevin. So Kevin Benning is with the Army C5 ISR Center. He started working there back in 2020 as the DMSMS team lead. And within the first year was able to complete a number of DMSMS management plans that eventually ended with them being awarded the DMSMS Team Achievement Award in 2021. Kevin has coordinated several seminars aimed at enhancing the knowledge set for the C5 ISR Center on topics like electronic part obsolescence management, counterfeit parts, part research and technical documentation, DMSMS contract language, International Institute of Obsolescence Management Training, and many more. And so we are very glad to have Kevin on board to give this presentation to everybody who is here. And so without further ado, I will hand the proverbial mic over to Kevin, and I will mute myself until otherwise needed. So Kevin, the floor is yours.
All right. Thank you very much, Brian. Appreciate the introduction. Hello. Can you guys hear me? Can I radio check?
Should be good, hopefully. Yep.
All right. And you got my slides. Good. Getting a lot of little cartoon thumbs up. Appreciate that. So everybody, thank you very much. As Brian said, my name is Kevin Benning. I am the C5 ISR Center DMSMS lead. And today we're here to talk about the connection between diminishing manufacturing sources and material shortages, otherwise known as DMSMS. Don't shoot the messenger. I didn't name it or give the acronym, so we'll call it DMSMS. That's the more palatable way to talk about that, right? And the intersection of DMSMS and additive manufacturing, sometimes referred to as AM. So have an agenda here today. So we're going to talk about DMSMS and obsolescence. Those are very similar, but not exactly the same thing. We're going to talk about the differences between a proactive versus a reactive position, the challenges and the resolutions that are available. Dive in a little bit into the offerings of AM. It's a very, very vast wilderness, but the C5ISR AM team has a handle on some of those skills. So we're going to be talking a little bit about that, and then how AM can be used to support DMSMS. So this is an interesting position to be in, right? I'm not exactly sure the background of every single person on the call here, right? But the people that I have talked to that are have signed up to listen, about half of them seem to be familiar with AM, but not the obsolescence angle. And the other half that I've talked to seem to be the opposite, where they are kind of familiar with some of the obsolescence challenges and situations, but are a little fuzzier on the AM. So my goal here today is to kind of gently cover both sides and kind of forge a path right down the middle, so we can all walk away at the end with a deeper understanding of how these two things are connected, how they can influence each other, and how we can kind of move forward and use both of those to solve the problems that we have. So first things first, right? Let's talk about the DMSMS overview. So as I said before, diminishing manufacturing sources and material shortages. So I'm typically not the read every word on the slide kind of guy, but this definition is important enough where it does warrant the exact every word. So loss or impending loss of manufacturers or suppliers of items, raw material, or software. And you can see with our nifty little chart there, right, that we have the whole kind of supply chain depicted there in a little cartoon way. And it's important to know that any part of the supply chain can be susceptible to little DMSMS issues. So obsolescence, right? Related to DMSMS, but not exactly the same thing. And this is interesting because this is defined in slightly different ways depending on the source, right? So one, the SD22, which we'll talk about that a little bit later, but that's kind of the official international guidance. That's kind of your true north on your obsolescence direction and guidance. So the definition that they use is when a part is out of date and superseded by something new, right? So DFARS, we're probably all familiar with that. That has a bit of a different definition, right? This is when the part is no longer available from the OEM or an authorized aftermarket manufacturer. The IEC definition is when the part is no longer in production from the manufacturer in accordance with the original spec, right? So a little change in spec, even if it's minor, the part's now considered obsolete by the IEC. So why do we have these three definitions up there? Well, it's really important that everybody is using the same definition when they're speaking. So if you and your team are talking about obsolescence, are you all in agreement on which shade of this definition of the word obsolescence? Is everyone on the same page? How about if you guys are talking with a contractor, right? Or you're writing your contracts, what does the contractor mean by obsolescence and what does your team mean by obsolescence? And in some sense, this might seem like a distinction without a difference, or it might seem a little academic, but I've seen it where people are talking past each other in there's kind of these marginal cases where it comes up where because people are using slightly different definitions, it did make all the difference. So this is important to note, right? There's also a note there at the bottom, right? Just because a part is hard to find doesn't mean it's obsolete, right? That is also very important. We and my team hear from engineers all the time where they say, well, it used to be really easy to get the thing we need, and now it got really expensive, so it's obsolete, right? Or, oh, well, we couldn't get it from the supplier. We had to go through a different supplier. We'd use an aftermarket supplier, so the part's obsolete. Not exactly true. not exactly true. Hard to find does not equal obsolete. All right, so let's dive in a bit for the relationship between DMSMS and obsolescence. So this is important to understand. So here's an example of one. You could have an obsolete item. It can go obsolete for many reasons, right? One reason is technological, right? Just the state of the technology has moved on. A DVD player is a great example of that, right? When VHS, then DVD, and then Blu-ray, and then, you know, who knows what's coming next, and all the way down the line. So DVD players are obsolete by technology. Okay, so on the other hand, we could have a DMSMS issue with microchips. We saw this with COVID, right? COVID, the whole supply chain for basically everything in the world got interrupted. People couldn't buy new cars because the microchips that the cars depend on were unavailable, right? So the whole car is just sitting there, almost completed, but not quite, right? So microchips can have DMSMS sourcing issues. So it's the difference between something being obsolete, something having a DMSMS issue, and then there can be an intersection, right? So DVD players, they're still available, right? You can still buy them if somebody were so inclined. And if during the COVID years you wanted to go buy yourself a DVD player, you would be facing an obsolete item that was experiencing a DMSMS issue because DVD players use microchips, right? So again, these are very interrelated. Often there is an intersection and kind of an overlap, right? But they're not exactly the same thing. And when we have to really drill down and get to the bottom of solving a case or solving an obsolescence issue, it is important to understand the different shades of these, right? And know exactly where we're talking about. As you can see with the little bumper sticker there at the bottom of the slide, at the end of the day, if you can get the quantities of the thing you need, you don't have an issue, right? So if, again, going back to DVD players, if you need one DVD player, and even though it's obsolete technology, and even though it might be having a microchip sourcing issue, if you can somehow find one, you're good. Mission accomplished, right? So we don't need to solve the state of the market. We don't need to solve the supply chain. Where the rubber meets the road is, can we get the parts we need in the quantities we need? And if the answer to that is yes, you're not facing a DMSMS issue, right? Now, this is the SD22. I referenced this a little bit earlier. Again, this is the international standard. This is the guidebook on how to put together a good obsolescence management program, a DMSMS program. Goes into a lot of detail. The most recent version came out in May 2022. It's available for free. The link is right there. You can grab the link from the slides, or if you Google, right, you can Google it and pull it up, free PDF. It's a lot of pages, right? It's probably nobody's idea of a quick read, but there's a lot of good information in there. It is worth becoming familiar with it if you really want to dive in and walk down the road of what does solid DMSMS management look like, right? From soup to nuts. This is where you find that. I'm going to save everybody a bunch of reading, and we're going to dive into kind of the core concept of the SD22. So if you want to do the long reading way, there you go. You got the link. For today, we're going to talk about this thing. So this is kind of the heart of the SD22. Oh, the DMSMS management process. They have a little pyramid there, right? Prepare, identify, assess, analyze, implement. That is the DMSMS risk management strategy. And it's also surrounded by the circle, right? Strategize, right? So we want to understand that all things go obsolete eventually. However, that doesn't mean that we need to handle every single part the same. So what do each of these little steps mean? Well, let's get into that. So prepare, right? That's you prepare the foundations for the DMSMS processes and the management. You identify the items with obsolescence risk, right? You assess when and at what level you would need to resolve the issue. So what they're talking about here, just these first couple steps. Let's say you have a BOM with 1,000 items. You can't monitor all 1,000 items with equal vigilance, in the same way that you can't necessarily have a backup plan in place for every single item. You triage, you go through the BOM, you say, well, out of the 1,000, what are the parts that are the most likely to give us a problem? Or what would be the parts that, if there were a problem, would give us the most catastrophic consequences? Those offenders, right? That's your little sub list. So maybe out of your 1,000-item BOM, maybe you got 50 parts like that. Those are the parts that you keep the closest eye on. Those are the parts where you start doing your detailed roadmaps, or maybe start setting aside some money for budgeting just in case you get surprised by something and you need to access some cash to implement the resolution, right? Those are the parts where you make sure you're not relying on a sole source, or you start working with your contractor to make sure things are a little bit more robust, or maybe you start doing lot buys ahead of time, be proactive, right? Those are the things that you pay the most attention to, so you don't get blindsided, right? So that's the early steps of the DMSMS process. So prepare, identify, right, assess, analyze, right? So now we're in the figuring out what we would do if there were a problem. So you analyze the most cost-effective resolution. If something comes up, if there is a real world incident and it needs to be resolved, right? You have your resolutions ready to go, implement the resolution, and strategize. Remember, that's kind of the circle that was around the pyramid, right? So this basically means pay attention to all the previous steps. Pay attention to what you and your team did. Pay attention to how you prepared, what you thought would happen. Pay attention to what actually happened, and course correct, right? So, hey, we did a good job. We planned ahead really well. Implementation went great. We properly anticipated the problem. Good. We're going to copy paste that. We like that. We want to keep that. Or say, well, we did okay, but there are some things could have been a little better. With hindsight, here's what we should have done. Okay, note that. Adjust your plan moving forward, right? So that circle, that strategize surrounding the pyramid, that's the be mindful of what you're doing and iterate and try to improve it every time. So, and all of these steps apply through the life cycle. Something worth noting is a lot of people, when we hear DMSMS or we hear obsolescence, the picture that people get is they say, oh, that's the thing that happens when something is in sustainment, right? Or it happens near that transition to sustainment point, right? Or, oh, that happens when the system is at cruising altitude, 15 years into the system or 10 years into the system, right? That's the attitude that many people have. So what we would like to do is kind of change that perception. The attitude should be, we are planning for this as early as possible, preferably in the design stage. I was at a conference recently and I heard that 60% of systems go out the door with obsolete parts already embedded in them. So 60%, right? And maybe that could never be 0%, right? Maybe that some of that is not avoidable, but 60% is pretty high. So we need to be planning as early as possible, right? It's kind of like saying, oh, planning for retirement, that's what old people do. Say, well, no, old people need their retirement and the planning starts when you're younger, right? That kind of thing. It's never too early to start. And so that we're pushed to the left. That's the thing that we're trying to impress upon people, is it is not a sunset year of the system kind of a thing. Good obsolescence planning starts as early as possible because we know it's going to happen, especially with microelectronics, right? Okay, so what are the positions we could talk about? So as I was just kind of implying there, right, is we could be in a good spot, right? We planned early and often, right? We anticipated what we know is going to happen in some form, right? Or that we call that a proactive solution. So an item is going to go obsolete at some point, right? We don't know maybe the exact day. We're not predicting the future, but we can get a rough sense, right? There can be an 18-month cycle on some microchip, or 18-month cycle on some microchips. Maybe hardware needs to be replaced. Your car's oil changed every 3,000 miles, right? So lubricants, adhesives, they have a shelf life, right? So we're not exactly predicting the exact date, but we can get some estimates. It's not like we don't know anything, right? Or we don't have any guesses. So an item's going to go obsolete at some point. What we want to do is be paying attention to that as early as possible, so we discover or anticipate when the item will be obsolete, right? Or will be a reasonable time for us to do a switch, right? We want to give ourselves that window of time to solve the issue before the DMSMS program is impacted, right? So if we're doing everything properly, we are constantly monitoring and replacing and swapping items and doing refreshes before there are any downstream effects or bumps in the road, right? That's a proactive situation. That's where we want to be. Here's where we don't want to be, right? Reactive. So an item goes obsolete and we find it out later, right? We find it out, hey, why are we having all these problems, right? Why are things not operating properly? Oh, we dug into it. Turns out this thing is obsolete. That's bad, right? Or, oh, we need a quantity of these that we can't get in a time that we need it, or we can't afford, the cost has gone too high. Poor planning, right? Now we're in a giant time crunch, and now our DMSMS program is impacted, right? That's bad. Reactive position, that's where we do not want to be. Or at the very least, the compromise, right? I talked about earlier about scrubbing the BOM. Can't monitor everything with equal intensity, so we trim down to find what are our most likely candidates to be troublemakers, right? We at least want to be monitoring those proactively. If we're in a reactive position for our likely troublemakers, we're going to have a bad time. That's where we don't want to be, right? So, all right. So what do we mean by proactive precisely? What does proactivity mean in terms of practices or activities? So monitoring and surveillance, right? I kind of talked about that before. You know, you're constantly keeping an eye on the parts, especially the ones that you think could be offenders, right? So we're constantly canvassing the market, making sure that we're keeping up to date. There's also data management, right? How is our data captured, cataloged, utilized? Where is it stored? How pure is it? What are we doing with it? What's the form? We're not just capturing data to say we did it. We're actually putting it in some meaningful form or chart. We actually understand what we're doing with it. I know easier said than done, but it is important. Roadmaps are classic data visualization tool. That's kind of when it helps you get an idea of when you need to do a tech refresh or a tech insertion. Roadmaps are dependent usually on the type of item. Again, a microchip is going to have a different refresh rate than something that's, you know, hardware based like a screw or a bracket, right? But well, it does need to be charted out. Risk identification, that's what I alluded to before. You're scrubbing your BOM and you're saying, what are the items that are most at risk to either go obsolete or most at risk, or put the system at the most risk if something goes wrong with them, right? Two lenses, but both important, right? System readiness, health evaluation, that's checkup. You go to your doctor, right? Does your blood work, your weight, your height, all that stuff. And he gives you a little report, says, here's the state of your health as of right now. You do that, except it's for your system. And then case management, right? So what do we mean by cases? It means, okay, we got an alert. Alert told us to look into something. And we said, yeah, there actually is something, potential problem here. We need to dig into it and figure it out, right? So that's a case. The kind of gut check for this, or the example that everyone can kind of relate to, you have a problem with your computer, so you email IT, right? And what do? They say, thanks for emailing IT. We're going to look into your problem. Here's your ticket number. We'll get back to you in 2 weeks and we'll give you a status update, right? And then they either say, good news, we fixed the problem, here's the resolution. Say, we couldn't fix the problem, so here's what we recommend, right? And eventually they close that little IT ticket. That's what we're talking about, except it's not about IT necessarily. It's about, what are the problems, right? We use 1,000 of this part every month, and it looks like we're only going to be able to get 400 of that part every month starting next month. I have a deficit of 600, right? That's bad. Open a case, look into it. What are we going to do to fix it, right? We figure out the solution, close the case, implement resolution, we're good to go, right? So that's what's meant by case management. If you're doing your case management properly, the cool thing is you start to get a backlog, and then you can start to pull reports off that. You can say, hey, I've noticed that when we open cases that have to do with these kind of parts, it takes us 8 months to solve it, versus these other kind of parts, we solve it in 2 months. Why is that, right? And you start to get that kind of the metrics and the picture of how you're actually handling things, and that can reveal ways that you can improve and be more proactive. So that's kind of interesting. That's kind of a downstream thing, but it's really neat when that starts to happen. So proactive DMSMS efforts beyond that, right? There's other things too. funding? Is funding in line? Is contracting on point? Do you have a plan, right? DMP, DMSMS management plan, where you and your team have sat down and said, all right, let's scrub our parts. Let's imagine a little bit if something were to go wrong, what would we do to fix it? You know, that kind of thing. Did you have your tech data squared away? Are you training people, right? Or if your people need training or lack this knowledge, are you bringing somebody in to raise the level of what they can do, right? And it's this kind of collaborative strategy amongst your team, amongst workforce development, sometimes between governments and contractors, to make sure that you people have all the information you need to make the right decisions at the right time. So common challenges here. So what are common challenges that a lot of teams face when it comes to DMSMS? Funding is a big one, right? There's not enough funding, or it takes too long to get funding. That's a very interesting problem to have. It's one thing to say, oh, the solution costs $1 million and we don't have $1 million. But what do you do when you say solution costs $1 million and we can get $1 million, but that'll take us 9 months and we need the solution in 6 months, right? What do you do if you can get the money, but it's just an internal process? It's too slow, right? Or it's just kind of a policy thing, right? Or the color of money, right? Or the speed at the leadership moves, right? That's very interesting. And that's a tricky thing too. But that's a big challenge a lot of people face, not just the quantities of money, but the time it takes to get it. So what about lead time, right? About getting the parts that you need, or it's if you need parts machined or made or a factory to start production up again, which a lot of them will do if you talk to them and you kind of get it worked out ahead of time, right? But what if that takes too long? You know, how is that resolved, right? And again, it's a different kind of problem when you say the solution we need is out there, we just can't get it in time, right? So how about economy of scale? That's another big one. So, oh, we need 1,000 of these parts, and factory says, well, we only do production lines of 10,000 at minimum. Are you gonna buy 10,000? I mean, how are you gonna resolve that? You know, and that's something else that's a struggle. So another one, right? Parts change, technology drifts, form, fit, function, right? So you think about a mouse, you know, in the way the ports have changed, right? You'd have to look far and wide to find the old school PS2 port mouse, right, versus USB. USB might go out. It might all be Bluetooth, you know, in the near future, right? And that opens up problems too. I know government computers are not supposed to use Bluetooth interface devices and all that stuff, so that opens up security problems. But the point is that at the just natural drift of technology, you might hit a point of no return, right? And what do you do about that? So often, and this is where things get even more complex, it's usually not just one of these challenges or just one of the bullets under one of these challenges. Oftentimes it's many. These are stacked on top of each other. These are very complex problems. This is why the best thing to do is to do your planning, your DMP, right? Your DMSMS management plan. Get the team on board, get them educated, get them talking the same language. Plan early, get in a room, go through your BOM, imagine worst case scenario. If we walked in tomorrow and found out we couldn't get this critical part, what would we do? You know, how would we solve that? So as far as DMSMS resolutions, I have this in here as a reference. This is pulled from the SD22, but it's still good to see. This are the official codified ways to resolve a DMSMS case, and it's broken down by the frequency of their appropriateness. And this is kind of interesting because if you're on a team and you have an obsolescence issue, you guys are sitting around putting on your thinking caps and you say, you know what, we've really done our diligence and we think that a complex redesign is absolutely the way to go. This is a good gut check because you say, well, the averages say complex redesign is appropriate 0.4% of the time. Are we super confident that we are squarely in that 0.4%? Or is there a different solution we could implement? You know, is there a similar but different resolution? You know, what are the odds that we are in that narrow slice and that we have picked the appropriate solution, right? So that this again, it's not a law, right? But it's kind of just a good gut check to let you know about what you feel are appropriate resolutions, how frequently they really are the appropriate resolutions. So this kind of keep you on track sometimes, or at least make you think a little differently. So here's the goal, right? This is the goal of everybody, right? we want the quality triangle. Ideally, we want to be dead middle. Kind of unattainable, right? But we've probably all seen this kind of a thing before. But fast, cheap, and great. We want to maximize, but oftentimes not. And if you have an obsolescence issue, if you're in a reactive position, you're going to have to pick which thing you don't want. Do you want your high cost? Do you want your low quality? Or do you want your long duration, right? And there are no solutions. There's only trade-offs. And the earlier we plan, the more proactive we are, the more we imagine early and plan ahead, the closer we are able to drift to the center of the quality triangle here. The more reactive we are, the farther we will be from the center. So let's talk a little bit about additive manufacturing, and we're going to start to see how this connects to DMSMS, right? So again, definitions, just throwing it out there because AM can mean different things to different people. So the official definition, right? Process of making a three-dimensional solid object of virtually any shape from a digital model using an additive process. Successive layers of material are laid down in different shapes, right? So there's some sub bullets here, kind of worth throwing out there. There's 7 commonly accepted types. There's subtypes under those 7 types, and it kind of branches all the way out. It's a very complex ecosystem, right? But the good news is it's a very rapidly growing industry, right? So even though it's a very complex ecosystem, there's always somebody out there inventing the next thing or leveraging the new technology that comes out, or working with the existing machines and finding new ways to combine them. So it's very exciting. There's a lot of dust being kicked up and a lot of gold being discovered in the dirt there. So 3D printing, right, is what everybody, that's what the mind goes to, right? But that is not straight additive manufacturing. That's a subset, right? Because this is what most people think of, right? So when you talk about AM, this is what everybody thinks of as nerds printing stuff. And God bless them, we need people to do this. And we have people on my team that do this, and it's great. There's good value here. But there's more than just this. So my team here, MRIB, Manufacturing Readiness Industrial Base Branch at C5ISR. We have a lot of different slices to our team. One of them is our AM team. And I worked closely with them to help put some of these slides together. I'm not the ultimate expert on AM. I know a bit, but not the ultimate expert. These guys are. But printed electronics is a very, very good slice of the AM tree. There's a lot of things happening here, and there seems to be a lot of opportunity, right? So again, AM, big umbrella. Hybrid manufacturing of electronics is kind of a sub umbrella, and in there, printed electronics is a really good opportunity space. So this is where the additive manufacturing process, or multiple additive processes, these are used to create functional electronics or components. So some of these might seem familiar, right? Some might strike you as brand new, right? That's okay. But there's screen printing, there's direct wire, right? And that includes, everything from dispenser to aerosol jetting, depending on your application. Inkjet, right? Think more or less like your inkjet printer, right? Except you're printing directly onto, the electronic board right there. There's a bunch of others too. So again, a little more niche, right? But they all have their applications and their uses. So everything cold plasma jetting, nano imprinting, the transfer printing and stamping, right? And you also, have your offsets in there too. So again, a lot of different ways to approach this, a lot of different angles, and depending on the particular situation that somebody is trying to resolve, some of these make more sense than others. But we can actually go a layer further, right? So this is just the printed electronic stuff again. So this narrow slice of hybrid, right? That there's even something else, like complementary kind of branch, I guess you'd say. So this is the supporting manufacturing. So what do we mean by this? So supporting manufacturing, this is where you're blending the AM ability with traditional manufacturing thing, right? So polymer, the deposition, right? Your laser etching, robotics and automation, the micro milling. Have a few other things here, right? Electro and electroless plating, right? So plating, you get a part that's printed. You can then go and plate it with the material, usually a metal that's stronger, right? So you get the flexibility of printing a customized part, and then you're kind of imbuing it with the strength of the coated material down the line. Very cool stuff. Curing and sintering, UV thermal things like that. But the idea that you're enhancing traditional manufacturing with the flexibility of 3D printing, right? So there's a lot of cool opportunity spaces here, and there's a lot of different ways to skin the cat. So why are we talking about all these, right? Well, the typical mindset that we run into, because I'm not sure if everybody on the call is an engineer. Probably not every single person, but I have a mechanical engineering background. A lot of the people I work with are mechies or electrical, and a lot of the people that we help and talk to have that engineering background. And so something, if anyone here knows engineers or you are an engineer, we like stuff. We know we get very excited by the technology, and so the mindset when we talk about AM is usually this. This stuff is cool. It's the future. Feels like Star Trek. The future's now. We can print anything we want, right? That's very neat. However, we need to update that mindset, right? So I'm crossing that out, right? In terms of usefulness, in terms of the story that we can use to persuade and sell to leadership, the people that control our budgets, right? Or the people that we're asking to slow down and plan ahead. Our mindset needs to evolve, and that's all of us together. The mindset we need to embrace is that AM can help you sidestep your supply chain issue. So where the rubber meets the road. It's not just that it's cool technology and it's neat to do the future stuff. It's that we can actually be very targeted with implementing these solutions through AM and not have to go down the road of pain that we would normally face with an obsolescence issue. So I brought back a nifty little graphic there, right? What happens if you have a sourcing problem with raw materials, right? What happens if you have a manufacturer, and who knows what could happen to them? Wiped out by a hurricane. Maybe they're located in a politically sensitive region, and now due to geopolitics, we don't have access to the materials or the raw materials that are needed for a manufacturer to do business as usual, right? All kinds of things can disturb the supply chain. AM can step in and help solve some of these. So what are these big benefits of AM, right? What happens here? So cost, that's a big thing. A lot of these applications, it's cheaper to 3D print, especially for production runs. We talked about that earlier, right? You have an obsolescence issue where you need a limited number of critical parts, and that is way below the minimum buy for a manufacturer or the minimum a run of what a manufacturer would do to start up material again. AM can step in and help you. You can optimize your swap there, right? Your size, weight, and power. So we all know with AM, you can get the unique topologies. You get strength in ways that you might not get to with a traditionally manufactured part. You get the unique designs, right? Things that can't be made traditionally, or even if they could be made traditionally, would be very expensive, right? Or a very, very unusual process due to the shapes. The reduced part count is very cool, right? The fact that you can make something with completely internalized gears or parts, right? It all in one cohesive state, right? You get a lot of benefits with that. Waveguide, we have the example of the 3D printed waveguide there versus the 5 waveguides for a system. Again, the time, all things considered, it's relatively quick to do printing. Once you kind of get your act together with what you need, it's pretty quick. You also get the point of need printing. That's a whole other thing, right? Where you have guys in the field where they need to print, if they need brackets or, they need something in the field. If they have a printer with them, you can shoot them the files and they can do quick Band-Aid fix on the need or point of need printing, right? So there's so much flexibility in this, right? So the idea that AM can be used to sidestep a lot of these supply chain issues, AM can be used as a method. AM is not a solution to a DMSMS or an obsolescence issue. It's a method to implement a solution, right? And this is something on the table that needs to be folded into our decision making and our planning. So again, a little bit about the audience here today, right? I know some are government people, and some of them may have heard me speak before. God bless you. Thanks for showing up again. But we also have a lot of people outside the government too. We might even have some people from industry or small business, right? So if you're outside the DoD, you're interested in doing business with the DoD. This is a little primer on how to make that happen. So again, if you want the full size of this chart, so all the links are live and all that stuff, you can hit the web address there at the bottom. And again, this isn't, the little legal caveat here. This is not a guarantee of DoD business or anything like that, right? But we know that the government is a big building and it has a lot of doors, and this can help narrow down the doors that you have in front of you to go knock on. So if you're interested in doing business with the DoD, I highly recommend checking this out. If you are working with a company who has AM abilities or AM solutions, and you think that people in the DoD would benefit from them, this is a good way to go. So kind of wrapping up here, DMSMS and obsolescence, significant risk to the sustainment of systems. The opportunities here to create the solutions that we need, it's interdisciplinary. It's not going to be solved by one person, one department, one method. It's going to take all of us working together. And, we need to do the planning ahead to be proactive, as I said. But this new technology that's out there and the flexibility that it offers, it really is worth all of us coming together and having an informed discussion about, so we can be very nimble when it comes down to implementing these DMSMS solutions that we need. So that being said, I have a handful of slides in the appendix for anybody that wants to grab the slides and review the appendix on your own. Go for it. If you have questions about any of that stuff, you can reach out to me directly by email. That being said, just want to open up the floor to any questions and answers there. Brian, I don't know if you have any questions coming in through the chat that you want to toss out, but
absolutely. And in fact, if you can see, maybe if you could find that section, that way you can read along. But I'll read them out loud, give you an opportunity to respond to them.
Okay, great, thank you.
And actually, before I do, I just saw a chat here come in to everybody. Just want to reiterate that shameless plug for you, Kevin, doing another webinar on November 16th for DAU on designing for resilience. So the link is in the chat for everybody to check that out.
Yes, thank you for mentioning that. And that I should point out, the Designing for Resilience DAU webinar is actually a panel. So it's not just me. I'm hosting a panel. We get 4 SMEs, inside and outside government. So that it's going to be a very, very good discussion, and designing for resilience, right? So it's all about what's it look like to plan ahead? What do we mean by that? What do we mean by plan? How far ahead is plan ahead? What do we mean by resilience and good design? What are examples of successes and failures and all that stuff? So it's going to be a very, very good panel. It's not just me and a couple slides. It's me and some friends.
So something new. So if you're here today, there's going to be something new there. Okay, good.
So thank you.
All right. And so then just a quick reminder, there is a Q&A section within the WebEx platform. So if you have a question for Kevin, please find that. You might need to click the 3 ellipses, 3 dots there to find the section for Q&A and just drop your question in there. All right, so in order that they were received, first question is asking, have AM vendors, as far as you know, have AM vendors worked out how to replicate material properties created due to work hardening, surface nitrating, or similar processes?
There's a good question, and I don't know. The card that I'm going to play here again is I'm not the ultimate expert in the details of the AM processes.
Right.
So the good news is I work with guys that are. So the super detailed questions, I'm happy to table and flip over to my MRIB colleagues here that do the AM stuff in the weeds day in and day out. Happy to get those collected. I can chat with them. We can put together actual written responses, send it out as a PDF.
Yeah, well, and there are a fair amount of questions here that are focused on AM, so that might be the card you play for a couple of these. But I'll just put out a blanket comment too, and or recommendation that DSIAC, one of the services that we're funded to perform, is a technical inquiry research service. So for anybody who's supporting the DoD or government in some form or fashion, if you have a technical question, throw it our way. And the whole reason we exist to help find information to give you an answer to that question, give you a head start. So we're happy to help try to answer that question as well. We've got a host of SMEs that we can reach out to get information. So we're another resource as well. But all right, fair enough. So the next question that came in was asking, has there been larger discussions at the PEO level to decide which supply class 9 parts the Army would be willing to utilize AM for? Understandably, AM can resolve many issues, but they're realistically temporary solutions until material quality increases.
So I'm gonna answer that in a slightly generalized way. Okay. I'm not privy to the particular PEO discussions that may or may not be going on. So the short technical answer to that is I don't know. The slightly broader answer that I am familiar with is that this is why we are having the discussion now and trying to get things started in terms of AM and resolutions, is to normalize AM being a method used.
Mm-hmm.
And so much of the policy right now, and you kind of get this chicken egg thing. Did the thinking beget the policy, or did the policy beget the thinking, or does one keep the other in place, right? But right now, a lot of the policy, the funding, the way the words are, the tenor of the meetings is very much, yeah, we have our typical ways to solve problems. And there's that weird guy with the science project in the corner that prints things sometimes, right? Good for him, but what are we going to do to fix the problem? We're trying to break that down and to at these higher level discussions, including budget, policy, leadership, say, look, we have actual things we can do with AM that can fix these problems. And we can't answer every question in terms of, yeah, okay, we know that a printed AM solution now probably is not going to last for 20 years, right? We can, we don't know that, but we're probably pretty sure that it's a temporary thing. But temporary doesn't mean it's a 1 week fix or a 1 day fix, right? We got to get some data. We have to start using the technology to get solutions so we can answer those questions. So now this is chicken and egg the other way, right? Is they want the data and the stability of knowing exactly how the AM solutions hold up. But we can't get that if we're not implementing solutions using AM to get that data in the first place. And so we need to break that cycle, or else it's going to be 10 more years and it's still going to be typical business as usual methods to solve the problems. And now it's still just the guy in the corner with his AM machine, right? That's how leadership sees it. We need leadership to be a little courageous and say, you know what, I'm going to take a chance and I'm going to use some of this AM stuff, even if it's in limited capacity, even if it's in a low stakes environment. We got to start building that data set of what it looks like to have resolutions that rely on these AM technologies, so we can start asking questions and be more secure to do larger scale, higher stakes resolutions.
Yep. That's a fair response to the question. It is a big question. How about, so the next one is asking, as far as you know, is the Army currently using AM to the level that you discussed, and is it being used as a solution to address certain parts that do meet specific criteria?
Yeah, to my knowledge, yes and no. I can say I know there's point of need things like I'm speaking a little generalized here, but you have soldiers in the field. They need brackets on the helmet to hold a flashlight, something of that nature, right? Something that is hardware heavy. That's not a microelectronic type thing. It's not a printed circuit board. It's more hardware based, right? You got guys in the desert, they need this thing, and it takes who knows how long or how much money to get the official thing out there. Can they print themselves a Band-Aid, right? Also, I've heard cases of vehicle repair, right? Like, hey, it costs an exorbitant amount of money and time to get the official OEM. What was it? Not rear view mirror, it's a side view mirror assembly, right?
Mm-hmm.
To get that shipped out from a manufacturer, when the guys can point of need print something, right, after talking with somebody stateside for 3 days. You get the CAD thing designed, or you get the file designed, you email it, and boom, now they got their truck repaired. And it keeps the mirror on the side in a stable way that's good enough for the next month that they need it, right? So there are those, I have heard of those point of need kind of things where it is used. Generally, so far, the stories I've heard are more that stuff. It's more the mechanical, the more hardware based solutions, but they are out there. And
Mm-hmm.
if anybody who knows soldiers or guys in the field, that they'll tell you, be like, look, if I have a need for something, I need it. I need it fixed. I don't care how it's done. If I need this, I need it. I'll ask questions later. And AM can definitely step in to solve that. So far, it's been a lot of the hardware, but I would not be surprised as time goes on, we see more and more of that being electronic, print electronics related.
Right. Yep. Good point. I'm seeing the future with you. How about next question is about the durability. Says what about the durability of an AM part for standard part? And again, venturing more into the AM specific topic field, but maybe you can comment on that.
So that is interesting. That generally, I would say generally the previous answer I said about we need more implementation with AM to get a higher data set, right?
Mm-hmm.
And then we're able to really make that strong comparison between durability, right? I will say this though, I have seen, again, talking about these like brackets or more mechanical parts. I've held these things in my hand, and I've held the traditional part and the printed part, and the topology of the printed part very different, right? And that this is where the special sauce of AM comes in, is they say, well, we could print a 1-for-1 clone of the official part that we're replacing, or we can do we do our digital tests and our modeling, and we find a shape that's better optimized. Now it's not really a straight apples to apples. It's Apple to like super Apple, right? Because now it's like, well, you could have used the original part and you got X in terms of your durability, but because we printed, we changed the topology, which you couldn't do with the traditional manufacturing, or it would have cost 10 times as much to get that topology with traditional manufacturing. But we could do it printed wise, and now it's X versus X plus 30% in terms of strength, right, or performance. And so those are kind of gains that we're leaving on the table by not implementing. That's like undiscovered benefit that we don't find if we're not implementing solutions and able to play around and explore, right? So,
yeah, good points. How about the focus of obsolescence when it comes to AM and the intellectual property of the design? How does that all play out? How do you plan out, for future of obsolescence for parts when you have to consider the intellectual property of the design that you can print with AM?
Oof, I wish I had a great answer for that. At this moment, my best answer, and this might not be the best answer, right? I'm certain there's people out there that would have a more informed answer than this. So my answer here is a little thin, and I'm being cagey here with these caveats, right? But this is, to my understanding, this is still a little Wild West, a little undiscovered country. And to that soldier in the field that has a machine and has an immediate need, IP might not be top of his list of concerns, right? When he's got an immediate need for something in the field. And if he has a printable file, he's going to do what he feels, he needs to do. There's that. But I understand. And I think most people would say that's different than, people in the lab saying like, well, we got some time, we're trying to solve a case, could do traditional manufacturing, we could do our thing here, and I've heard some very interesting discussion about this. Is there a counterfeit part, or is the Army now making a counterfeit part, and I don't think so. I don't think so, right? But this also could be solved through contracting in the future, right? And again, this is going to be, we need people to be brave enough to take the first step and say, I'm going to implement solutions with the method of AM in a controlled, measured, monitored way, and I'm going to see the benefit that yields. And if it seems to yield benefit, then we'll do it again. And if we're still yielding benefit and more benefit and more benefit, maybe now our discussions at the contracting table are different in the future.
Yeah.
And maybe and I don't know what that looks like exactly. We're not exactly there yet, but maybe it becomes something like the government reserves the right to print the IP in a limited amount or something of that nature, depending on the following circumstances. Like that could be possible, but maybe we don't really feel the importance of that yet. Maybe we don't fully understand the weight of that yet. If we don't have the data set that we get by using AM in our resolutions.
Yep. That definitely good to kind of think through and plan about it. In fact, the next question is kind of on similar topic, asking for AM to work, do we need, or do you need I'm sorry, I skipped the wrong one. Are there sources of independent contract AM parts now? And will there be in the future? Seems like that might be a cost-effective DMSMS mitigation option.
You say I'm sorry.
Independent contract sources of independent contract AM parts now, and I'm not sure what that might mean. For free to print kind of parts now, if that's what that means, you don't need a contract particularly for it.
Just kind of public domain parts, I guess you would say.
Perhaps, yeah. I'm not sure if maybe you had more insight on what that might entail. Yeah, AM for hire. Okay. Yeah, something like AM for hire, with just a quick, I guess it still would involve contracts, but a quick hire AM design, AM part. And how might that affect DMSMS and part obsolescence?
Yeah, I think that would be super cool. Is that say, hey, we have a, my weapon system has this obsolescence need. We're doing our diligence of implementing solutions. Traditional manufacturing would take this amount of time, cost this amount of money, or whatever, right? Like our government AM people would take this amount of time and this amount of money to do it in-house, right? But maybe something goes out to bid. And it's just, hey, here's what we're looking for, a limited run of this thing. Can you do it in this time, meet these these specs, and be under this dollar amount? And maybe, there's just a bunch of independent, non-government, right, vendors out there just bidding, so like, we can do it. I mean, that happens in construction, all the time. Whiting Turner, whatever, sends out bids like, hey, we need subs to do this thing. Here's the details of the job. Give us your best offer. And let's talk. I mean, I'm a free market guy. I like the sound of throwing something out there and being like, hey, we got this project. We need somebody to do it, and having a bunch of AM vendors chip in. I mean, that's where the innovation happens, and that's where you get to meet people, and you say, well, we used these guys last time. They were okay. Maybe we'll try a different guy, a different team this time. And hey, they were fabulous. Look at all the great stuff they can do. They could really help us out in the future with some other need, and that's how you just, again, there's kind of that churn that happens, and that's good for everybody. I'd love to see something like that, but time will tell.
Yeah. Yeah, I can imagine it being kind of a pre-vetted group of performers, so it's not just totally open to anyone who wants to come in, but maybe there's a select group of pre-vetted folks who just kind of streamlines the final decision.
Yeah, and pre-vetted, I think is a good term, right? I mean, it's not like we not going to throw the bid out on Facebook and get like some high schooler doing his science project. Like, oh, I printed 10,000 of these circuits for the Army, like that's probably not what the future would look like, but yeah, but pre-vetted legit companies that do work, and have the capacity to meet the need and have the pedigree, and the experience,
Right. Yeah. Well, hey, I'm gonna call it here because I want to honor our hour here, and I know a fair amount of folks have to drop off as well. There are a couple questions that came in that are still kind of out there. I appreciate all the questions that came in. I think Kevin, your email was dropped somewhere in the chat, so folks might reach out to you. Again, I want to reiterate the opportunity to reach out to DSIAC and submit a technical inquiry. We might reach out to someone like Kevin to get some answers to your questions, but we can help answer questions as well. But with that, I'll conclude our time. Thank you, Kevin, for your time, for the presentation, and wish you best of luck, especially next week for your panel discussion then.
Cool. Appreciate it. Thank you very much. And thank you to all of us attending. Appreciate the time and attention. Appreciate the questions, and like I said, I'll be able to go through with my AM guys some of the more detailed questions and see if we can get some detailed responses. So yeah, thank you, everybody.
Good. All right, thanks.